Hello and welcome back. As we near the end of the course, we come to maybe the most difficult topic of all of them. How do we choose RDM systems? I think it goes back to the question, what do we actually need? First, we need to brainstorm what you want the RDM system to include. We probably want metadata management. We need to think about data storage, so that implies what kind of data do we have and how much of it do we have. Do we have samples that we need to track? Probably yes, so we have to have some system of tracking samples. You will also likely have some sort of inventory, like all the instruments, all the computers, the consumables, anything that is related to the research that we're going to do. Ideally, our RDM system is also coupled with the electronic lab notebook, because we will likely have a lot of files from our scientific instruments. We would need some automatic way of extracting metadata from those files and ingesting them in our RDM system. If we want to share data, we want to have fair data objects. And if we want to work with the RDM system, we need to think about if we want to integrate analysis environments into the RDM system or if we have everything externally. How do we want to share data with public repositories? Is there any support in our RDM system for it, or do we do this manually ourselves? It's not just the repositories as such, but we likely want to open up to collaborations with other groups. So how do we actually do that? We also need to think about what is our anticipated usage pattern. How do we use the RDM system in our day-to-day research and practice? So essentially it boils down to which problems do we want to solve. And then we need to make a list of what is really essential for us, what is desirable, and what would be nice to have, but it's really just an optional goodie. This is not a decision that can be made once and for all. It really depends on your specific needs within your research group. Of course, these needs may also change, and once you've started, reversing major decisions is difficult. On the other hand, don't become paralyzed. You need to start somewhere. So it's best to take a few days and also talk to your various team members and see what your requirements really are and try to map this out in a brainstorm map. The first major decision that you need to take is if you want to go for a commercial or open source solution. You can go for a commercial RDM system, and that has the advantage that operation, user onboarding and training and support is done by the company, at least ideally, that provides this commercial system. The question is, are you allowed to buy such a thing from the grant money, from your funding? And the next thing is, what about updates and feature requests? Research data management is also about long term. So what happens not now or in the next 2 years? Can you have some sort of trust that the company will be there in 10, 15 years time? And what happens if they don't? Will you get access to the system? So if they go out of business, for example, you can at least maintain your installation for a while you have to migrate somewhere else. What about your specific needs? Is there a way to add custom extensions to the system, or is it locked down? What about metadata extraction? You will likely have a number of files that you acquire from your scientific instruments, and you can extract metadata from them, at least in principle. Does the commercial system allow you to do that? And how will it integrate into your group IT setup? Is it a local on-premise installation? Is it a cloud installation? How do you interact with local machines and your local instruments with that commercial system? Open source, on the other hand, is run within your own IT setup. That can be an advantage or disadvantage depending on your capacities and competencies within the team as well. On the plus side, you have no fear of the company disappearing and taking all the data with it, but you need to sort of have trust that the system you're going to choose is actively developed, not now and for the next 2 years, but also for 10, 15, 20 years time. Is it a small group project centered around one developer? And if they do something else or move somewhere else, the whole project dies? Or is it maintained by a larger collaboration? Or is there some commitment from a large institution to it? Of course, nothing is guaranteed forever, but small projects often die if the developers do something else. Open source, at least in principle, can be extended with custom integrations. The question is, how easy is that, and is it feasible that you can do it yourself? Now that we use an open source system that runs with our own IT setup, we need to think about operations. That means installing, running, and also updating the RDM system, but it also includes user onboarding, support, security patches, and so on. Again, think about the long-term perspective, not just the next 2-3 years, but what happens in 10-15 years. So neither approach really is free. It depends what you can and what you want to spend money and effort on. That may not be a decision you can make freely. Funding agency requirements or grant monies may prohibit you from certain choices. It also depends on the skills and competencies within your group. Who operates the system, who does the user onboarding, who does the user support, and so on. Of course, there's a third alternative: build your own system, maybe even starting from the little project in our course. So is there really no system available that fits your needs? But if you go down this route, you need to be sure that you have access to sufficient and professional developer skills in your group. It's not something you can, for example, do with one person for 1-2 years, and then the person, for example, may move on to a different institution and you are left with a system half installed on your system. You need to have some sort of long-term commitment for development and maintenance and so on, also after 10 years. So if you really want to build your own system, by all means go for it, but double and triple check that you can commit to such a choice. The next major decision that you need to take is the data model. The data model defines how the various entities are represented, or if links, parent-child relationships and hierarchies are possible. It's essentially a choice of the back-end technology, how to store the data and metadata. Here you broadly have the choice between relational databases like SQL type databases and NoSQL type databases. And this influences how you work with metadata. It affects how and what you can query, at least efficiently, how the data are represented in stores, and how to handle data quality issues or not. This is also another fundamental choice that cannot be undone later. Well, you could, of course, have a lot of dedicated migration effort, but it's really a lot of effort. So you really need to think about if a relational data model with a defined database schema is the way forward for you, or if you want to go down the NoSQL route. Not all choices you can make are free for you to choose. You may have some external constraints. So before you embark on the mission of actually committing to one system or another, try to find out which choices are already made for you by the funding agency or by your institution or university. These include some examples here. For example, you may already have an existing RDM system in your group and your university, and you may or may not be forced to use that. If it's already there, it's good to evaluate if it fits your needs. But if it doesn't fit your need, it's also not good to try and force yourself into it. Maybe some parts of the system already exist that you have to use and you can't get funding for alternatives. For example, a central storage service or backups or whatever. If you process personal information, you need to be GDPR compliant. So that can add quite a lot of overhead and hassle. And the same includes if you have sensitive data from industry projects or medical or other relevant sensitive data. Maybe your grant excludes certain software models like a subscription. Maybe you can buy on a one-term fee basis but not on a monthly fee. You will also have to think about how to integrate the RDM system in your IT security setup. And that is essentially related to how you want to automate metadata extraction or connect to the instrument hardware to automatically capture part of the data at least. So you need to think about if this is possible and feasible, and also if you have the right expertise within your group. Remember that this is a long-term commitment. If you operate your own system, developing custom software, or if you commit to an external vendor, you need to think on the timescale of decades and not years. One way of helping you make a choice, at least for electronic lab notebooks, but not for the laboratory information system, is the electronic lab notebook finder operated by TU Darmstadt. So that can give you at least a few pointers of what's out there and how it would match your requirements. Last but not least, think about your users. How does the system look from a user perspective? Is it easy to use? And easy to use depends on your user base. Depending on where your users come from and what they are familiar with, easy to use can be very different between groups. So you need to think about and also engage with your potential users if such a system is intuitive for the people that need to work with the system. That may depend on the level of technical expertise, and maybe you need to cater for casual and power users. How easy is it to integrate the RDM system into their daily workflows? And how do you bring the users to engage with that system? So here you really need to think about benefits that affect users directly. Of course, you can tell them about good practice and long-term perspective, but typically that's not an immediate benefit the users will care about. So when you introduce a new RDM system, think about what users gain for themselves on a short time scale, which benefits they have in their personal daily work. Choose wisely, and unfortunately there is no easy way out of this because the requirements vary from group to group. It's best to start out thinking, maybe even pen and paper, and map out your needs. What do you want the RDM system to do? Which problem to solve? And then, unblemished from everything that's out there, imagine your ideal outcome. If you had the perfect RDM system, what would it be? How would it work in practice in your group? Now add the constraints that are already there from funding agency, other decisions taking, university, and so on. Then think about the data model. Think about if you want to go down the route of commercial or open source software or even develop your own system. And then think about your group, how to integrate the system both with the IT setup and with your users. So step by step, you then move your ideal outcome and bring it in contact with the reality in your research group. So map out the requirements. What does your ideal system look like? What kind of problems do you want to solve? What's optional? Which constraints do you need to consider? Many decisions need to be made very early in the process. Unfortunately, a number of them are very fundamental and difficult to change later. But don't get paralyzed. You need to make a decision, and making a decision is better than not doing anything. What are users comfortable with? Any system that you want to introduce needs to be used every day by the users, and the users need to be able to use it and also want to use it. So as a set of exercises, build a map of your potential solution space. What are your requirements and ideal outcome? And then add the constraints in the data model. Once you've done this, find the available RDM systems that match your needs and see if you can find an existing RDM solution that matches to what you want the RDM system to do. Then list the pros and cons for each of those and determine how you would decide which of those criteria of the pros and cons would actually be most relevant to you. Maybe you have an ordered list of criteria, a list of must-haves and nice-to-haves, and then try to match the RDM systems against such a list.